This is a tangents and normals question. It's taken from a past exam paper. This paper was C1 January 2011. It's worth 12 marks in total and it's question 11, so towards the back end of the paper. So the question says, the curve C has equation y equals a half x cubed minus 9x to the power of 3 over 2 plus 8 over x plus 30. Where x is positive. In part A for 4 marks, we have to find dy by dx. Part B for 2 marks, show that the point P, which is 4 minus 8, lies on C. And in the final part of the question, for 6 marks, find an equation of the normal to C at the point P, giving your answer in the form ax plus by plus c equals 0, where a, b and c are integers. Okay, so part A, find dy by dx. Okay, so I'm just going to write y as half x cubed minus 9, that's minus 9x to the 3 over 2, plus 8x to the minus 1, plus 30. So I've just changed that term there so I can see what the power of x is. And I've done that because when we differentiate, we multiply down by the power and subtract 1 from the power. So I'm doing this in full detail for those that don't entirely understand differentiation. 3 over 2 times 9x to the power of 3 over 2 minus 1. 3 over 2 minus 1 is a half. So we have a half there. Then we've got minus 1 times 8 times x to the minus 2. And constants disappear when you differentiate. They have a 0 gradient. So tidying this up, this becomes 3 over 2x squared minus 27 over 2x to the half and minus 8x to the minus 2. Okay, so that's dy by dx. It hasn't specified any format, so it's okay to leave like this. And that's for 4 marks. So moving on to part B. Show that the point 4 minus 8 lies on C. Okay, so C has the original y equation. So if x is 4, y has to be minus 8. So we need to show this. So let's put x equals 4 into this. So 1 half times 4 cubed minus 9 times 4 to the 3 over 2 plus 8 over 4 plus 30. Okay, so what is this? So 4 cubed, we do the powers first. So a half times 64. Now this term here is slightly tricky. I have to use the Indices Rules to do this. So 4 to the power of 3 over 2 can be written as 4 to the half, then to the power of 3, because when I multiply powers, I can separate them in this way. So 4 to the half is the square root of 4. This is just 2 being cubed, which is 8. So I've got minus 9 times by 8. 8 over 4 is 2, and then 30 on the end. So 32 minus 72, which is minus 40, plus 2, which is minus 38, plus 30 is minus 8. And that's the desired y coordinate. So that's for 2 marks, that's done. And in part C, find an equation of the normal to C at the point P, giving your answer in the form ax plus by plus c equals 0, a, b and c are integers. Okay, so I don't know what this curve looks like, but I do know that if I've got some curve like this, here's a tangent at some point. If the gradient of that tangent is m, then the normal, which is perpendicular to the tangent, will have a gradient of minus 1 over m. So I need to find the gradient of the tangent first, then I can take the negative reciprocal to find the gradient of the normal. And I find the gradient of the tangent by finding the gradient of the curve. So how do we find the gradient of this curve? So I have to differentiate and put my x value in. So I've already differentiated in part A. My x value is 4. So I need to put 4 into dy by dx. So we need to put 4 into this one. Okay, so that's going to tell me the gradient of the curve at that given point. So dy by dx at x equals 4, so at x equals 4, dy by dx equals 3 over 2 times 4 squared, minus 27 over 2, 4 to the power of a half, and minus 8 times 4 to the minus 2. Just about squeeze that in. Okay, so that's 3 over 2 times 16. Minus 27 over 2 times 2, so that's just minus 27. Minus 8 times 1/16. Okay, so 3 over 2 times 16, so take half of 16 is 8, times that by 3 is 24. Minus 27 minus a half, that's 8 times 16 on the end there. So 24 minus 27 is minus 3. Minus a further half is minus 3.5, or minus 7 over 2. So I have the gradient of the curve at x equals 4. So I have the gradient of the tangent to the curve at x equals 4. And I have to do minus 1 over this. Minus 1 over minus 7 over 2. To find the gradient of the normal. So multiply top and bottom of this by negative 2 becomes 2/7. Right, so the gradient of my normal is 2/7. So we're halfway to finding the equation of the straight line. So a normal has as a straight line, so it's a very shallow gradient. So if we roughly guess that my normal looks a bit like this, I know that it's y equals mx plus c, but now I have the gradient, so 2/7 x plus c, and I can use the point on the normal. We know that 4 minus 8 is on the normal, because we're finding the normal at that point, to help me find my plus c. So let's put y should be minus 8 when x is equal to 4. So that is minus 8 minus 8/7 to find c. So minus 64 over 7 is my c, because minus 8 can be written as minus 56 over 7. So minus 64/7 in total. So my equation of my normal in the form y equals mx plus c is y equals 2/7 x minus 64 over 7. But if we remember in the question, we're asked to put it in a specific format. Ax plus by plus c equals 0, where a, b and c are integers. Not confusing that c with a y-intercept. So these are not integer coefficients at the moment. So by multiplying both sides by 7, I will obtain integer coefficients. And it has to be right-hand side equal to 0. So what I can do is subtract 7y from both sides, and just put my 0 on the other side. So 2x minus 7y minus 64 is the equation of the normal. If those signs were reversed, so if you had a 7y minus 2x plus 64, for instance, that would also be accepted. So we've got the equation of the normal in the specified format, so we have completed the question. So go to studyworld.com for more of this.